Hello friends, welcome back. And in the previous video, we discussed about the TF-IDF vectorizer, that how actually the fit transform and the transform methods work. Just to revise, that fit transform method works on the training set of data, and the transform method works on the test set of data. Test set of data is there to just validate your model, because test set of data is taken apart from the entire set of data with the with the predicted values that we are expecting to be predicted, right? So we have created a model which will predict. So for training that model, we are using the fit transform method, and after fit transform, we are assigning the same transformation to the uh, test set of data. And once you do that, and you are able to find out whether the test result set is giving the data which is nearly equal to the as per the model which is predicting the values, then we say that our model is good, right? So in continuation of that, I would like to tell you something about the count vectorizer as well, although we have discussed about this in one of the previous videos, but it's still just to be in a continuation, and just to conclude this vectorizer thing and this fit transform versus transform methods for all the different kind of vectorizers. I'm going to discuss about it, and it's very simple. Just like for the TF-IDF vectorizer, we have the count vectorizer, and fit transform method, it works on the training set of data, and the count vectorizer transform method, it works on the test set of data. Okay, and with the help of this transformation, you can predict the values. And you have seen the code in the you know one of the previous videos. I have also shared in one of the videos in the description section for the the code, right? So in this video, apart from discussion on this count vectorizer, I would like to say that you can refer the count vectorizer here. So in this video, in one of the videos, I explained about this. If you remember, then you can understand, like you can remind yourself that yes, we have discussed this one, that how the fit transform works and how it actually reads each and every word and how it assigns the counting, right? So it creates a complete list of all the unique terms, and then it gives the count in each of the document. So this is the set of words from all the documents. It could be 1,000 documents, it could be 100 documents, it could be any number of documents. So from those set of documents, it is creating a single list of all those terms which are available. And then for document 1 and document 2, if the quick word is available in the document 1, it will give 1. And if the quick word is available in the document 1, then it will give 2, because quick word was available twice in the document 1. Similarly, if it comes to brown, then it was available once, and if you go to fox, then it was available once in the document 1. Similarly, in document 2, the this word the was available, and then quick brown fox, these words were not available, so the placement holders have been given 0 value. And then lazy and dog, both were available in document 2. So for the lazy, the value 1 can be seen, and for the dog, the value 1 can be seen again. So this is how the count vectorizer behind the scene works. But yeah, the transform and fit transform methods, you know the purpose now, right? So now in the second part of this lecture, we are going to discuss like how you can save your model, onto the hard disk or onto some storage device. Because every time you cannot run your machine learning model, and every time you load all your training data and start training, that doesn't make any sense. So basically, the thing which makes sense is that you use the training data once, and once you have trained your model, and once you have the vectorizer available, which you apply on the, which you use to apply it on the input data for the transformation, those two objects should be saved. So always remember that two things you need to save here. One is vectorizer data, and the other one is the data with the the classifier, multinomial NB, the Naive Bayes classifier. This object also you need to, save, because in this predict sentiment method, if you see, I have just commented it because I have written another method, another Python file where I have just opened this model, the objects of this model, the Naive Bayes classifier, and the vectorizer object. Both I have opened, and then I have used them to predict on the input data. Okay, so if you see here, when it was earlier there, this code was there earlier. So you can use this new code now. I will provide both the code pieces into the comment section or the description section, wherever I could fit it, because sometimes in the description section it doesn't allow to use some certain specific symbols. So that's why I have to put it into the comment section, and I need to just pin it. So I will pin it. So here you can see we have used the vectorizer and we have used the classifier, Naive Bayes classifier. Both the objects have been used to actually predict the sentiments for the input text, right? So both these objects, vectorizer and the Naive Bayes classifier, both must need to be saved somewhere on the hard disk or into some storage device, right? And you can give some version number to that as well, your model. Okay, so we are going to save two things. One is the classifier object and the other one is the vectorizer. So you can see here, after the TF-IDF vectorizer, I have done this thing. Like I have opened a file in the binary mode, in the writing mode, in the binary mode with the writing, I want to write it, and in the binary mode, right? So I have created one file, tf-idf underscore vectorizer.pkl, because I'm using the pickle here to serialize, just to persist my model, right? So vectorizer I have shared, saved using the tf-idf vectorizer, and similarly the count vectorizer I have saved here using the pickle only, and I have given the name count underscore vectorizer.pkl, and I have opened the model again. I have opened the vectorizer again in the writing mode with the binary mode of operation. Okay. So pickle.dump function is used to just save it. And here also I have done this dump method used. And here also to save the multinomial Naive Bayes classifier, I have used the pickle object and its dump method to save the Naive Bayes classifier on the hard disk. So I can show you that where these have been saved. So let me open this, reveal in File Explorer. So you can see Naive Bayes clf.pkl, count vectorizer.pkl, and then tf-idf vectorizer.pkl. All these three files are available here. Okay. So these three files have been persisted here. Okay. So rest of the code inside the same file I have commented, because I don't want to use this file again and again. This file, this program will run only once. Okay, or it will run every time till you get a perfect model, till you are able to find out that yes, my model is giving me the correct result based on the test data. Okay, so that's why this particular piece of code I have commented, and it will run last time when you have find the perfect model, and then we come to another file which is sentimentclient.py. So we are creating another program, and this program, the purpose of this program is to just load a model, the existing model which has been trained already. So here what I have done, I have just opened the tf-idf vectorizer here. I have loaded it. So I have opened the vectorizer using the pickle. So you have to import the pickle module if you want to use the pickle, and after that you just need to do this thing with open, and then you need to write the name of the file you want to open, and then you need to open it into the read mode with the binary mode. Okay. So loaded vectorizer is pickle.load. We have loaded it, and if you want to load the count vectorizer to predict the sentiments, then in that case you can load the count vectorizer as well. You just need to rename it. You just need to rename it to this one. Okay, let me see where it has gone. Yeah, so here if you see, you can open the count underscore vectorizer.pkl if you want. So you can open it here, count vectorizer.pkl in the read mode, and then you need to open the Nave base classifier. Okay, so you open both the objects, the vectorizer object and the classifier. Okay, it's multinomial NB, it's not monomial NB. It's spelling mistake, multinomial, multinominal. Okay, multinominal NB. Okay, so Navy base classifier object we are opening, we are loading it, and after loading it, we are just defining a function predict underscore sentiment. The input is the text, and then there is a text underscore count, loaded underscore vectorizer dot transform, and then clf dot predict text count. You can see that these two things we have already done in here, which we have commented. So the same thing we are doing here. So we have to use a model using this piece of code. You have written your own model. You have your own data. You have trained your own model, which is known as sentiment.py, and then you have saved it. Then you have saved your machine learning model, and now you are using the same model after opening the vectorizer and the classifier objects after loading them, basically. So this is how it works, and then here is the while true, which means like I will run this loop infinitely, and in every call I will just ask the user to enter the text, and then it will predict the sentiment. So let us run it. So it is running here. So it is asking me the text, enter your text. So, hi, this was really not a good EXPERIENCE. So it will give you -1. And you know that we have assigned -1 for the negative sentiment. Now I'm going to write, it was an awesome EXPERIENCE working with all of you. So you can see there is some kind of training data which is missing. In case of awesome experience, this is something like very positive thing, but yeah, it is giving me -1. If we write like it was good, then it will give me 1, which is positive sentiment. But yeah, for this awesome experience, somewhere my model have not got this awesome experience thing, right? So it is not aware that it is a positive, it is used in the positive context. So you can go to the CSV file and you can add some line which contains, or you can add some paragraph which contains this word awesome, and then you can train it to have some kind of uh, sentiment which is 1, right? And you can write like it was nothing special. So it gives you -1, negative sentiment. So you need to train your model more, uh, which is in the CSV file, all the data in the CSV file. So you need to just provide some kind of statements like it is nothing special, it was usual. In that case, it is something like we are neutral. It's neither bad nor good. It's usual service we have already seen everywhere, right? So you need to train it, right? Because there is a very small set of data that we have used. And based on that data, it is able to predict the sentiments for some of the sentences correctly, but for few of the sentences, it is not able to give you the output correctly. Okay. So we are going to train the model again. And I think I have shown you that how you can use a new text and how you can provide a sentiment value to that. So I think you can use that, and with this, I think all the things related to the sentiment analysis on a beginner level to understand, I think you have understood it correctly. And after this, we are going to start into a new model, which will be image processing machine learning model. Okay. So till then, have a nice day and bye bye.